Unit 16, Part 1. Unit 16 is on invalidity in quantifier logic. So recall what it is for an argument to be valid. An argument is valid when it's not possible for the premises to be true and the conclusion to be false, right? A valid argument is one where the truth where we've got an argument is a set of sentences separated into premises and conclusion, where the premises give you reason for believing the conclusion, and a valid deductive argument, the only kind we've been concerned with, is one where the truth of the premises would force the conclusion to be true, right? If the premises are true, then it's necessarily the case that the conclusion is also true. So what is an invalid argument? An invalid argument is one where it is possible for the premises to be true and the conclusion to be false, right? An invalid argument is one that leads us from truth to possible falsity, right? One where we're not assured of the truth of the conclusion given the truth of the premises, okay? In this chapter, we learn how to prove that arguments in quantifier logic are invalid, right? So arguments in quantifier logic are just arguments where the premises and the conclusion are themselves quantifier statements, or where the premises and the conclusions are conditionals or disjunctions, but where maybe the subformulas are quantifier statements. So arguments in quantifier logic are just arguments that where the statements in part or in whole are quantifier statements, involve quantifiers annexed to propositional functions, or are singular statements, the analysis of which we began only in this quantifier logic. Okay, so we're going to prove that argument. We're going to learn how to prove arguments are invalid in this logic. You will be presented. Okay, this chapter, Unit 16. You do not have to. There's 3 sections. You do not have to worry about the first section. You will not be asked. The first section is on the natural interpretation method for proving arguments invalid. I won't ask you about this in the exam. You don't need to worry about that. You can skim through the first section, but you do need to read and study the second and third sections of the text, where you're given. The second section is on truth conditions for quantifier statements, and you need that in order to be able to do what you'll be asked to do. Section 3, the model universe method. The model universe method for proving arguments invalid. So I do promise you that in the exam you will be asked, you will be presented with an argument in quantifier logic, so an argument that with quantifier statements as parts or wholes of the premises and conclusion. And you will be asked to use the model universe method to prove that this argument is invalid, right? So why do we use the model universe method before we get to what it is? So as Klenk begins in Unit 16, do read the introduction, right? What we've been doing is proofs, right? We just finished a long Unit 15, 17 videos, 17 parts. Where we're proving an argument valid, right? If you can give a proof, right, using the rules of sentential logic and the new rules for quantifier logic, then you've proved that the argument is valid, that the conclusion does in fact follow from the premises, right? All those rules are truth-preserving, right? They move from, they move in such a way that if the premises of the rules are true, the conclusion follows of necessity. Excuse me. So whenever you find a proof, you have got a valid argument. But as Klenk points out, just because you can't find a proof doesn't mean the argument is invalid. Maybe you just haven't tried hard enough, whatever. So how do we prove arguments are invalid? We have to return to the semantic method, right? So second paragraph of page 299, first page of this chapter. What we need to do is revisit the semantic method and reintroduce the notion of a counterexample, an instance with true premises and a false conclusion. So you remember a counterexample has a long history in our course. Went back to Unit 5 when be going through an example from Unit 5 in a moment. But if you remember back to Unit 5, which is when we learned the truth table test for an argument's validity, right, which was the climax of that first part of the course, the exam was after Unit 6, first exam, where you could actually take argument forms, where we'd learned the truth tables for all our sentential operators, our truth functional sentential operators, the wedge, or, the dot, and the hook, so on and so forth. And we, when presented with an argument form, right, where all the formulas are presented with sentential variables, we could test that argument form for validity. Remember, a particular argument is valid if and only if the argument form is valid, and the argument form is valid if and only if that form has no substitution instances where the premises are all true and the conclusion is false. Such a substitution instance of an argument form, one where the premises are true and the conclusion false, that's a counterexample, right? So if you remember back to our truth tables, we would construct a truth table with the base columns, right? All the sentential variables would be listed true, false, true, false, true, false, right? And we would list all the possible combinations of truth values for those atomic units, the sentential variables, right? And we would compute in columns the truth values for each premise and for the conclusion, and we would look for a counterexample. That is, we would look for a row in that truth table that made all the premises true and the conclusion false. If we found such a row, we would point to it and say, that's a counterexample. The existence of this counterexample proves this argument is valid. Right? Sorry, yeah, it proves it is invalid. The existence of this counterexample proves that this argument form does have a substitution instance, I'm pointing to it, where the premises are true and the conclusion false. And so that showed that any argument that was of that form, any particular argument with contentful English sentences, if any particular argument that had that form was itself invalid, even if it led from true premises to a true conclusion, we wouldn't have the necessity of the connection between the premises and conclusion, which is what deductive logic's about. It's necessary that if the premises are true, the conclusion is true. That's a tight deductive argument. So we're going to be doing something similar in quantifier. We're going to be doing something similar here. We're going to be on the search for a counterexample for arguments in quantifier logic, right? So what I'm going to start by doing is revisit first of all, the short truth table method for proving an argument invalid. And this is an example from where we first learned that. We learned that in Unit 15. We didn't really, we went through it in the lectures, but we didn't use it in the exam. I said you wouldn't need it for the exam, but you need it for later. Now is the later. Okay, now is when you need it. So we had the full truth table method in Unit 5, where you construct a whole truth table, you look for that counterexample, you find one that proves the argument is invalid. But then we looked at the short truth table method, which was where, when you remember for a truth table, you have to, if the argument has only two sentential variables, like modus ponens, P or Q, P or Q, second premise, P, third premise, Q. There's only two sentential variables, only 4 rows needed for the truth table. If you had 3 variables, though, to exhaust all the possible combinations, right? If you've got P, Q, and R, you need 8 rows, 4 variables, 16 rows, 5 variables, 32 rows. It gets big pretty quickly, right? So we had another method for honing in on a counterexample when there are quite a large number of sentential variables. And that was the short truth table method, right? So I'm going to do an example from that to remind you of what honing in on a counterexample looks like, because we're going to do something similar. So I'll start part 2. When I start part 2, I'll do this example. This is from the exercises 3D. And I'll remind you of how trying to hone in on a counterexample, right? Trying to hone in on a on a particular interpretation of the sentential variables, and by interpretation in the semantic method, I just mean, right, an assignment of truth. What we're looking for is this. We've got all these sentential variables, P, Q, R, S, and T. That's all of them, right? We want to find a counterexample. That is, we want to find an assignment of truth values. Remember, the truth values are only true or false. Those are the two truth values. We want to find an assignment of truth values to these sentential variables that makes the premises true and the conclusion false, right? And that's just a matter of wielding our knowledge of the conditions under which disjunctions are false and conditionals are false and biconditionals are false, so on. So I'll remind you how that goes. You might want to look back to this section. Also, I'll point out to you chapter 9, section 6, where Klenk talks about invalidity there. Again, that's what she's referring to when she starts this Unit 16, saying, as we saw at the end of Unit 9, the proof method can only be used to show that arguments are valid, but not that they're invalid. Right? So that's all page 191 and 2. So you can look there as well to remind yourself of what's happening. But anyway, I'll go through this so you have a reminder of what we're doing. And then I'll teach the big lesson from section 2 of Unit 16, which is what it means for a quantifier formula to be true or false in various domains, right? Because what finding a counterexample, what proving an argument in quantifier logic, what proving that an argument in quantifier logic is invalid by the model universe method, what it's going to involve is translating, right? So the next thing will be translating quantifier statements into truth functional statements, right? And there'll be different translations in different domains, but that translation will allow us to reduce the problem of finding a counterexample to a truth functional one, right? The translation will move us from quantifier statements to truth functional statements. That is, statements where the major operators are conjunctions or disjunctions or whatever, hooks, biconditionals or whatever, negations, as opposed to being of quantifier form. And that allows us to use this. That's what allows us, or makes possible, the use of the semantic method. Okay? I'll hopefully say that more clearly as we go on. All right, I'll come back in part 2 and do this problem.